Ever wondered what would happen if you fell into a black hole? Or what exactly a black hole is? These questions have intrigued scientists and stargazers alike for centuries. The mystery of black holes is as vast and as deep as the celestial bodies themselves. A black hole, in its simplest definition, is an area in space where gravity is so incredibly strong that nothing can escape its pull. Yes, you heard it right, nothing, not even light, the fastest entity known to us. This is why we call them black holes. They are invisible to the naked eye, shrouded in a darkness that even the brightest stars cannot pierce. But how does something become so voracious? Well, black holes are not your ordinary celestial bodies. They are the remnants of massive stars that have exhausted their nuclear fuel. When these stars collapse under their own gravity, they leave behind a small but incredibly dense core. If this core is above a certain mass, it forms a black hole. Now, let's imagine for a moment that you're on a one-way trip to a black hole. As you approach, you'd start to feel the gravitational pull growing stronger. This is the point of no return, the event horizon. Once crossed, there is no coming back. You'd be stretched into a long, thin strand of matter in a process we call spaghettification. Not a pleasant journey, right? Black holes are not just fascinating, they're also extremely important for our understanding of the universe. They challenge our perceptions of physical laws and force us to question our understanding of the very fabric of reality. Despite their ominous reputation, black holes don't go around devouring everything in their path. They're quite the cosmic paradox, representing both the end of life, with their insatiable appetite for matter, and the birth of new galaxies. So a black hole is a region of space where gravity is so strong nothing, not even light, can escape. But how do these cosmic beasts form? Stay tuned to find out more about the intriguing and mysterious world of black holes. Black holes don't just appear out of nowhere. They are born from the remnants of massive stars. Think of the life of a star as a constant tug of war between gravity pulling inward and nuclear energy pushing outward. For most of a star's life, these two forces are in balance. But when a star exhausts its nuclear fuel, gravity gains the upper hand. Now, what happens next depends on the star's mass. For stars with a mass approximately 3 times or more than that of our Sun, the gravitational pull is so strong that it overpowers all other forces. In the absence of the outward push of nuclear energy, these stars collapse under their own weight. This implosion triggers a spectacular explosion known as a supernova, which can outshine an entire galaxy for a brief moment. But the spectacle doesn't end there. The core that remains after the supernova is still massive and continues to collapse under its own gravity. Eventually, it compresses so much that it essentially disappears from the visible universe, leaving behind an enormous gravitational pull. This is the birth of a black hole, a point in space where gravity is so strong that nothing, not even light, can escape. But let's not get ahead of ourselves. It's not like these celestial objects are popping up left, right, and center. They're relatively rare, and their formation is a cosmic event of epic proportions. It's like the universe is holding its breath, watching a star live out its final moments in a blaze of glory, only to give birth to a mysterious entity that defies our understanding of physics. Black holes are truly fascinating, aren't they? Born from the violent death of a massive star, they're the ultimate symbol of transformation in the universe. A place where matter once shone brightly as a star now becomes a dark, invisible entity with an insatiable gravitational appetite. So a black hole is born from the violent death of a star. But what would happen if you fell into one? Imagine yourself on a one-way trip into a black hole. What do you think would happen? As we journey towards this cosmic abyss, let's ponder on the theories about what occurs when an object, say a spaceship or even a planet, falls into a black hole. The most widely accepted theory is that as you approach the black hole, the gravitational force at your feet becomes much stronger than at your head. This discrepancy would cause you to stretch out like a piece of spaghetti, hence the term spaghettification. A bit of a comical term for a not-so-comical fate, isn't it? Now let's talk about the event horizon, the point of no return. This is the boundary around a black hole beyond which nothing, not even light, can escape the immense gravitational pull. Once you've crossed this threshold, there's no turning back. It's a bit like a cosmic version of Hotel California. You can check in anytime you like, but you can never leave. But it's not just the physical implications that are mind-boggling. Time itself behaves differently near a black hole. Due to the intense gravitational pull, time slows down. To an observer far away, it would appear as if time has stopped for you, a phenomenon known as time dilation. So whether you'd be stretched into a cosmic noodle or frozen in time, a trip into a black hole would definitely not be your average joyride. It's a journey from which there's no coming back, a plunge into the unknown. But here's a thought. Can anything escape a black hole? It seems impossible given what we've just discussed, but as we'll find out in our next segment, the universe might just have a few tricks up its sleeve. So, a trip into a black hole would certainly be a one-way journey. But can anything escape a black hole? Is a black hole an inescapable trap, or can anything find its way out? This question leads us to the intriguing theory of Hawking radiation, named after the brilliant physicist Stephen Hawking, who first proposed it. In the mysterious realm of quantum mechanics, particles and antiparticles are constantly popping into existence, only to annihilate each other a moment later. Now imagine this happening right at the event horizon of a black hole. One particle falls in, but the other, if lucky, can escape. This escaping particle is what we call Hawking radiation. Over incredibly long periods, this process can cause the black hole to lose mass, and in theory, eventually evaporate completely. So in a way, black holes may not be the eternal prisons we once thought they were. Now, let's talk about another fascinating aspect of black holes. How do we detect something that's essentially invisible, something that swallows up even light itself? The answer lies in their immense gravitational pull. When a black hole passes near a star or a gas cloud, it starts pulling matter towards itself. This matter, while spiraling into the black hole, heats up and emits high-energy radiation, like X-rays, which can be detected by our telescopes. That's how we spot these elusive cosmic beasts. Sometimes, black holes also reveal themselves through their effects on nearby stars. For instance, if a star is seen orbiting an invisible object, or if its path is perturbed in a way that can't be explained by visible objects, then a black hole might be the culprit. Even though black holes are invisible, scientists can still find them, but how big are these cosmic giants? We'll delve into that in our next scene, where we'll explore the size, types, and future of black holes. Stay tuned as we continue our journey into the captivating world of these cosmic marvels. Black holes come in different sizes and types, but how big can they get? And do they last forever? Well, let's delve into this fascinating corner of the cosmos. Black holes are generally classified into three types based on their mass. Firstly, we have stellar black holes, which are up to 20 times more massive than our Sun. These are the most common ones, created when a star burns through the last of its fuel and collapses in on itself. Next, we have the supermassive black holes, which are at least 1 million times heavier than our Sun. These monsters reside at the center of most galaxies, including our very own Milky Way. The size of these black holes is mind-boggling. They can be billions of times larger than our Sun. Finally, we have the intermediate black holes. These are the mysterious middle children of the black hole family, with a mass between stellar and supermassive black holes. They're hard to spot, but astronomers are constantly on the lookout for them. Now you might be wondering, do black holes last forever? The answer is both yes and no. In theory, black holes can live almost indefinitely, but there's a catch. They can lose mass and energy through a process called Hawking radiation, named after the physicist Stephen Hawking. Over unimaginable spans of time, this process can lead to what's called black hole evaporation, the eventual death of a black hole. So, if you're worried about a black hole swallowing up our Earth, you can breathe a sigh of relief. The nearest black hole is over 1,000 light-years away, and even if one were to come close, it would have to be incredibly massive to pose any threat. So black holes are not only fascinating and mysterious, they are also diverse in size and type, and they even have a lifespan. And while they may sound scary, there's no need to worry about a black hole swallowing up our Earth anytime soon.